we can talk a little bit about parts of a triangle. So when you have a right triangle, you're going to see the box right there. Your hypotenuse is always going to be the longest side, and then you've got your leg, and you've got your leg right there. So we're looking here, what additional information do we need to do the hypotenuse leg theorem? Well, if we have this side marked congruent to this side, we've already got a leg. So with the hypotenuse leg theorem, you then just need the hypotenuse. So there's your hypotenuse right there. So if you can prove that that side is congruent to that side, so I'm just going to show with markings, those two sides are congruent, then you can now start to use the hypotenuse leg theorem. If you look at number 2, you've got this side marked. Only thing we would need to know here is if we have a right triangle. So there we could prove that that's going to be congruent based on that being a right triangle right there. And heading down to number 3, if we look here, we've got our hypotenuse marked right here. So if we just knew either this leg was congruent to that leg or vice versa, if you wanted to use this one down here, if you knew this leg was congruent to this leg, now you've got your hypotenuse leg theorem. And lastly, we've got our right triangle. You've got a hypotenuse cutting through the middle. That's also a reflexive. So again, if you could just prove this leg was congruent to this leg, or similarly, this leg was congruent to this leg over here. So hypotenuse leg theorem is limited just to right triangles. So when we start continuing working on our proofs, you'll be looking for those right angles. Once you know those right angles are in your triangle, then you can start to use that hypotenuse leg theorem. So one other thing that you may be wondering, so we do have the hypotenuse leg theorem. There is no like leg theorem. If you think about leg theorem, so if I knew this leg, and then I have this angle in between. If you know both legs with this angle in between, that's actually another theorem we've talked about. Does anybody remember what that other theorem was when you have a side with an angle in between and another side? That would just be an SAS. So there is no leg theorem. That would just be an SAS because you'd have a leg with an angle in between and another leg. So those would be proven that way. All right, so we've got about 3 minutes here. Let's just take a look at one problem from numbers 5 and 6. So we'll take a look quickly at number 5. So number 5 is asking for what values of x and y are the triangles congruent by HL. Set up a system of equations and solve by substitution or elimination. So if we have a right triangle right here and right here, if we can prove that the hypotenuses are congruent and then these legs are congruent, we can prove that the two triangles are congruent. But we need to find values for x and y that make them congruent. So we're going to set up a system of equations. So I'm matching up this hypotenuse with this hypotenuse. That's going to be x is equal to 2y. And then I'm also matching up this leg, x minus 4, is equal to y plus 3. Now we have a system of equations. We have two variables that we're using here. And to solve a system in geometry, how we start out, we are going to be using the method of substitution or elimination. Here I'm going to use substitution. This 2y is equal to x. I can put that in for x into my other equations. You're probably going to start remembering this from Algebra 1. Then I'm going to have 2y minus 4 is equal to y plus 3. So the x replaces out with the 2y. Then I can start to get my equation solved out. I'd get the y subtracted over, add the 4 over to the other side. I'd get y is equal to 7. Once I know y is equal to 7, now I can put that back up to here. X is then going to equal 2 times 7, which is going to be 14. So there's how I can find then my other value. So each of these problems here, we can use substitution or elimination. So you can try number 6 on your own. And the answer key should be posted so you can check your work. And sorry, I got a little sloppy here, but the y was 7, and then the x was 14 up here. So there's a problem where we can start to use that HL theorem and kind of mix in some Algebra 1 practice